Hello everyone. Today we are going to explain what a MAC address is. A MAC address is used to uniquely identify a network card within a network. Each network card must have a MAC address. For example, in the diagram we have here, each network card must have its own number called a MAC address to identify itself, just like everyone has their own ID card. The MAC address is globally unique and non-repetitive, and it is directly embedded into the chip when it leaves the factory, so we don't need to configure it at all. Now, during this process, we ask why we need this network card. Why do we need this MAC address? For example, during this process, I have a device here, and under this device, several computers are connected. For instance, here we have PC1, PC2, PC3, and also our PC4. In this process, if I want to send data in the future, how can I send it individually to the other party? How do I know what the other party is? It's because I can connect 1 to 2 here. 1 connects to 3. 1 connects to 4. Similarly, 2 connects to 3 and 2 connects to 4. Then 3 connects to 4. Here we achieve mutual connections. But in this context, we refer to this as direct connection. In this physical state of direct connection, one cable connects you and one cable connects me. So if all 4 devices are directly connected, in this process, what happens? We need many network ports, so what can we do? We can, although we don't connect directly to each other, establish a connection between us and the switch. For example, in this scenario, if these devices 1, 2, 3, and 4 do not connect directly to each other but all connect to the switch, then in this process, it is not a direct physical connection, but a logical connection. This means we are not connecting each device with a separate cable. In this process, if I connect my 4 devices as mentioned, I might need to connect 6 times. I don't need to connect them like that, but I can still achieve communication between any 2 devices. Here, through the switch, I can connect with you. I can also connect with device 3, and I can connect with device 4. This is called a logical, direct connection. It doesn't mean that one interface connects directly from my end to your end, but rather it goes through the switch as an intermediary, allowing me to connect to device 2. I can connect to anyone. I can connect to 3. I can connect to 4. And I can connect to 2. I can also connect to 3 and 2. And I can connect to 4. It's all possible. Now, in this process, logically speaking, all devices are in an interconnected state, which we can understand as being achieved through this switch. Achieving interconnection means that they are all on the same link. We are all just connected to this switch, and you can understand it as if we are all on the same link. The network connected through the switch can be referred to as the smallest, most basic form of a small local area network, LAN. In the future, when we plan, we generally assign them to the same subnet. Now, if I have a switch facing so many devices, how do I identify them? I will use MAC addresses to recognize them. You are only identified within this link. So, the MAC address, in this process, it will serve as a means of differentiation for us in the future. Here, this is our MAC address, which means every Ethernet device. Before transmission, it must have a unique MAC address. When this device accesses the network, it assigns an IP address to each of our hosts. As for our MAC address, it doesn't need to be configured. So you might ask, why do we have both a MAC address and an IP address? First of all, if we assign a unique IP address to each computer here. So why do we still need MIC here? Everyone should think about it. The reason is actually quite simple. Let's first look at the difference between the two. Our IP address is unique and it can change. It is assigned based on our network topology. As for the MAC address, it is also unique in this process and it cannot be changed. Besides this, the MAC address is automatically assigned by the manufacturer for us. So why do we need a MAC address when we already have an IP? The reason is actually quite simple. Isn't our IP assigned based on network topology? Our MAC address is assigned by the network manufacturer. Now, if during this process, based on the second layer, meaning that if I am searching within the same link, my device becomes more flexible and easier to maintain. If an Ethernet card fails, I can replace it without changing its IP address. If an IP host needs to move from one network home to another, I can assign a new IP directly to this host without needing to perform any operations. In this context, I also don't need to make any corresponding changes. If we need to change the network card, I can easily do so. Actually, the only difference here is the point of identification. If we want to precisely locate within my link, it is actually based on the MAC address. However, if we only have the MAC address and you are asked to find a MAC address globally, the scope is too broad, making it difficult to locate. So, we have planned the IP. We have learned about IP before. It has subnets, CA, based on the subnet it belongs to and the subnet assigned by the service provider. I can specifically determine the city it is located in. This way, it is convenient for us to address it on a global scale. Here we say that an IP address is essentially a unique network node. It identifies a unique node and allows us to use the IP value to access data from different subnets. Our MI address is the unique network interface card, and we can use the MAC address to access data within the same network. Now here we say the MAC address is assigned by the manufacturer. How is it divided? According to our MAC address, it is actually 48 bits in total. Within these 48 bits, the first 24 bits serve as a manufacturer identifier. In other words, which manufacturer manages and allocates it. Huawei has its own, Cisco has Cisco's, and Ruigi has Ruigi's. These 24 bits are our manufacturer identifier. Then what are the remaining 24 bits? They are allocated by the manufacturer itself. For example, Huawei allocates them on its own. In this context, it pertains to different product lines, such as what is a router in the product line, what is a switch. In other words, the last 24 bits are automatically allocated to the manufacturer, and you can allocate them however you want. The first 24 bits identify the manufacturer, and these first 24 bits are definitely different between manufacturers, so there won't be any repetition. How many permutations and combinations are there for those 24 bits? Each bit is either 0 or 1, so theoretically there are 2 to the power of 24 permutations and combinations. Just for the manufacturers alone, there are this many permutations and combinations. As for the IP address, based on the MAC address, it actually can't be exhausted. Well, and even if it were, it wouldn't matter because we will have some virtual MACs later on. Each manufacturer can also define virtual MACs, so there's no need to worry about it running out. Besides this, let's take a look at what a MAC address is and what it looks like. Here, let's take a look at the MAC address. A MAC address is 48 bits or 6 bytes. In the usual representation, a MAC address can actually be identified as 6 groups, either separated by colons or without them. This group composed of hexadecimal numbers formed by this delimiter. Now, in this process, actually each hexadecimal number in the future is stored in our devices in binary in our computers. If in the future you want to learn or understand how to convert hexadecimal to binary, you can look at each hexadecimal number as corresponding to 4 binary digits. Because in this process, we say 48 bits are binary, and in this process, what we will form in the future are 6 groups of 12 hexadecimal numbers. So now in this process, within this, you can actually convert and see that 4 digits here actually equal 1 hexadecimal number. Now in this process, it means that each hexadecimal corresponds to 4 binary digits. In this process, for each binary digit, if the smallest is 000, what is the largest? The largest is 1111. Here, when we convert it to decimal, the smallest is 0 and the largest is 8 plus 4 plus 2 plus 1, because they are respectively 2 to the power of 0 and 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. Each digit takes a value, which is 8 plus 4 plus 2 plus 1, equaling 15. So now the guessed range is actually from 0 to 15, which is actually the same as our hexadecimal system, because in hexadecimal, it carries over at 16. This means the maximum number is from 0 to 15. If we talk about it here, like we usually say, 1, 2, 3, 4, 5, 6, 7, 8, 9, it's very simple. But what about 10, 11, 12? How do we represent them? Because in this process, like the decimal system we are used to, it carries over at 10, in this case, our hexadecimal system carries over at 16, meaning the largest single digit can be represented as 15. So what do we do here? When we run out of numbers, we use letters to represent them. For example, in this process, they are 10, 11, 12, 13, 14, 15. When we represent them, they are respectively A, B, C, D, E, F. So the range of hexadecimal is 0 to 9, A to F. Now, if in this process, in the future, we want to convert a hexadecimal number into binary, how do we do that? For example, if I express 0 here in hexadecimal, 0 is just 0. For binary, I need to represent it with 4 digits, where each digit is 8, 4, 21. If a digit is used, mark it as 1. If not used, mark it as 0. So here, 0 is converted into binary as 0, 0, 0, 0. Then 0 is converted into binary 0, 0, 0, 1. For these 4 digits, let's see which digit is used. Certainly this one is used and the rest cannot be used. So they are marked as 0, resulting in 0, 0, 0, 1. As for our EE, in this process, when we say A, B, C, D, F, E, it actually represents our 14. If in this process it represents 14, then it is 8 plus 2 plus 4. So we take the value of these 3 digits, and the last digit is set to 0. In this process, this is how the calculation is done. Here we can convert hexadecimal to binary. So how do you convert binary to hexadecimal? In the future, for example, if we take this set of numbers, these 4 binary numbers, and convert them, it's actually our notation. The position of 8, 4, 21. I take the value as 8 plus 4 plus 1, 8 plus 4 plus 1 equals what? It's our 13. Now, if during this process we need to see what 13 is, A is our 10, B is 11, C is 12, D is 13. So in this process, this position corresponds to D. In this way, we understand how to convert hexadecimal to binary and binary to decimal. Now, in this process, as we mentioned earlier, a MAC address is actually composed of a manufacturer identifier plus our company identifier. That is to say, in this process, first, it identifies which manufacturer I belong to, and this is a globally unique identifier assigned by the IEEE. Besides this, the CIT is automatically assigned by the supplier or manufacturer, and these 2 components make it up. Now, apart from this, our MAC address is actually categorized. In this process, it is divided into unicast, multicast, and our broadcast. Now here we say unicast MAC address. It is also known as a physical MAC address. Unicast MAC is used to identify these terminals on our network, including our devices, combined banks. They actually all use this unicast address, which is our globally unique MAC address. The unicast MAC address is used to identify a single node in our link. Here, a destination MAC address as a unicast MAC address can indeed be sent to another node. The unicast MAC address can be used as either the source address or the destination address, but you must be careful here. We say that this MAC address is globally unique if there are 2 terminals with the same MAC address connected to a layer 2 network, for example, due to operational errors or various reasons, communication failures will occur at this time. Communication between those 2 terminals and other devices may also fail. Now, in this context, this is unicast. Besides unicast, we also have multicast and broadcast. If it's a broadcast, for example, you will find that its MAC address is all 1s. It's all Fs. At this point, it indicates that all terminals in our local area network have a broadcast MAC address, which can be considered a special multicast address. Here, when we say broadcast MAC address, it is written in hexadecimal as all Fs. The destination MAC for a broadcast MAC address frame will be sent to all on this link. All of this data. Besides this, we also have our multicast address, which is what we just referred to as multicast. The broadcast is considered a special type of multicast. Apart from our MAC address, if we are here, for example, when we used to take some computer classes, right? some microcomputer classes, if we are now in this context. We are all in one classroom, and our computers, along with the teacher's computer, are connected to a switch. Now, the multimedia teaching software that the teacher used back then is essentially this broadcast. Once the broadcast is sent, the switch will send this broadcast to all the devices connected to it. Now, in reality, all the gods, well, their computers are just, everything can be received and synchronized. Now, inside the room, there are also cameras. If the camera says, I don't want to receive it, but it's connected to this switch, if it's a broadcast, the camera will also receive the broadcast. It doesn't matter whether you want it or not, it's going to be sent to you anyway. At this point, it can receive it, but it doesn't want it. What can be done? There's no way around it. It just has to receive it. In this case, even though we say it's a waste of resources. It consumes hardware, but is there any solution? Yes, there is. Later on, only family members can receive the broadcast, while non-family members cannot. This way, resources are saved. The multicast MAC address is also used to identify a node in the link, but here we say it cannot be used as a source, only as a destination. For example, when we sometimes listen to radio stations, we listen to 99.00 max, and I'm just listening to it, just getting something from it. Can I say that I am it? No, I cannot. This is our broadcaster. Now, in this process, this is the meaning of our three types. If we convert this to our network devices, for example, if I am here, let's say we are now in a unicast. If, during this process, I now have a switch batterying with several devices connected below it, namely PC1, PC2, and PC3. Each of them is connected to the switch. Now, let's say I am PC1, and I want to send data to PC2. I only want to send it to PC2. Each device has a MAC address, and it's important to understand that for our device interfaces and network cards. For network device interfaces, if they have a MAC address, all the MAC addresses in use are unicast MAC addresses. This means that the MAC addresses configured on the device's network card are all unicast MACs. There won't be any multicast or broadcast. In our network, unicast is point-to-point. For example, if I am PC1, I will send a message specifically to PC2. And PC2 in turn sends a message specifically to PC1. This one-to-one communication is called unicast. It's similar to when we use social media apps to privately chat with someone. When I send data, I send it only to that person. I only want this data to be received by one person, and other devices should not be able to receive it. If we want to do this during the process, when I send data again, both the source MAC address and the destination MAC address must be for unicast. This is called unicast communication. So, you might ask, what does unicast look like? How do we identify a MAC address as unicast? How do we check it? You need to convert it into binary, converting the MAC address from hexadecimal to binary. If during this process, after conversion, we count from left to right, from high to low, and the 8th bit is 0, it indicates that it is a unicast. This is our unicast, and I can distinguish it based on this. This means that this bit is fixed as 0. Here, it indicates that data with this MAC address as the destination MAC address will be sent to a unique destination, meaning I only send it to that one. I send it individually. Besides this, we say that for unicast, its efficiency is too low. If I want everyone to receive it, then in this process, I need to send a broadcast. Broadcast within this. In terms of communication form, we call it point to multi-point. So what about this point? It must forcibly receive and process all communications. In other words, when I broadcast, you must receive it, and you must process it. So what is the data encapsulation format like? In the future, for example, during this process, let's say my source MAC address. For instance, if I am host A, I send a source MAC address. It is still unicast. But here, if the destination MAC is a broadcast. For broadcasts, it is mandatory to receive and process them. But now, in this context, if I want to send broadcast data, the source MAC is still unicast. But here, regarding the destination MAC, it is not about which position it is anymore. The 48 bits, all unique, if we convert this form into hexadecimal, it becomes all Fs. This is a destination for broadcasting. Broadcasting is aimed at everyone, and all devices cannot be used as a source, because when you talk about broadcasting, can you say, I am the broadcast? No, you cannot. This is also a concept of logical hierarchy. It can only serve as a destination address. Besides this, we also have our host, which is also in a logical sense, and it cannot communicate with others. Here, when targeting the destination, I communicate with all devices in the entire network, all devices on this link, which can be more efficient in terms of communication. However, in the form of broadcasting, it can generate a large amount of traffic, which may reduce our bandwidth utilization and affect the overall network performance. Moreover, in a broadcast network, all devices need to receive and process the data. So here we have our host. The host can be seen as selectively sending this broadcast. Specifically, our computers listen to specific host addresses and process them, and receive its purpose. The MAC address of the host is the frame for the host. When we talk about multicast hosts, it's like when everyone joins a new company, we often need to be added to the company's group. If we are added to the group, we can receive company notifications. If we are not in this group, then I won't receive them. Here, how do we distinguish between multicast and unicast MAC addresses? The 48-bit address from left to right must have the 8th bit as a 1 for multicast, while for unicast it is a 0. How is a broadcast MAC defined? If we want to perform multicast communication, the original MAC must also be a unicast. The original MAC is always unicast. As long as you send out this data, it is always unicast because it is generated by a device. And the device MAC is unicast. Now, in this context, if it's multicast, the destination MAC is our multicast address. In this process, the multicast represents a group, so it cannot be the original address. Because it is not a unicast, it is a logical address, not an address that can actually be configured on a device. It only serves as a destination. Now, in this process, A sends a unicast source, MAC. Let's assume we are A in this context. The destination MAC is a unicast. Now that I've sent it out in the network, it might reach B, C, and D. Will C process it? Here, we need to determine whether it should accept and process it. There is a concept called joining a group. Joining a group, we say that the unicast must join a group. If you want to receive this data, you have to join the group in advance. After joining the group, we can receive the data within the group. Before communication, each device must join the group. If you don't join the group, it means you won't be able to handle such multicast data. Even if you receive it, you won't be able to process. For example, here, B and D joined the group in advance, but C did not. So, if A sends a multicast, even if C receives it, it won't process it. If you join in advance, you can process it. Now, when a device joins a group, it's not done automatically. How does the device know it needs to join a group? In the network, there is a protocol called IGMP. So in this process, based on this protocol, it can join a group. The host has a problem. It has a family condition, meaning if the device does not join the group and the family does not manually receive the data, it definitely cannot be processed. For example, if this C does not join the group, the data will be discarded. So, if there is a high demand for timeliness, the host will process it relatively slowly. In the future, if I want to communicate with all devices in the network simultaneously, I don't need to join all the groups in advance. We can use broadcasting. When the device transmits again, it absolutely cannot lack this value. This is something everyone needs to pay attention to and understand. If in the future you want to learn more about technology, or if you want to study our Huawei certification technology, or wish to obtain the Huawei certification question bank, you can send me a private message. I can also leave more comments below the video for our technical exchange.